Hey everyone, in today's video we're going to see about vector database DB. And I'm going to teach you or explain like you're a 5-year old, I promise. So let's get started with. Don't skip any part. It is one of the important topic if you are working in LLM. So let's just have a smooth learning of vector database. So imagine you have a rack full of salt. So each of different color, and you have this rack which is like mixed up. All the socks are mixed up, and you're in a dark room where there's no light. So this sock have like different color like red, pink, black, white, off white, beige. I hope my handwriting is not clear, I know, but just understand the context. So you have like different colors. So all of a sudden you wanted to find a beige color. So you just going and finding that in the clumsy rack that you have. So each time you're trying to find a page, you're just getting a white, off white, or even red sometimes, but you're not getting a page. If you're like got to one, another one you're not able to find it. So what you will do is we just arranging the colors based on its similarity, like orange, pink, red will be in rack one, and beige, white, off white are in rack two. So each rack have a set of colors. With that, easily you can find your the colors that you wanted. Um, let's say you like again you wanted to have a page, so you'll go to rack two, and you can just find the beige color. And it is this time it is simple. You can just have like three options, and with that you can find the required color. So that's how. And if you ask me like how these colors have been assigned based on its similarity, it's because of the distance it has. In other way, we call that Euclidean Euclidean distance. Why my handwriting is bad? In general, I used to write it really well, but I don't know why here I'm not getting a good one. Sorry about that. So, you can use any distance metric. So that we call Euclidean distance or Manhattan distance. So this is how we can separate. And these rack one and rack two we can call as clustering. So cluster one, and here cluster two. So with that we can have a group of similar data assigned, and it is easy to fetch and get your output. So this is the entire clustering model. Now this is a simple ML model with a reasonable data. It is, when you're like going for any unstructured data and the data is like, reasonably small, and you can actually go for deep learning models also. But what if these socks are in millions of colors? How you can manage to have in a traditional ML clustering model? So with that, your large number of colors refers to your AI LLMs For that, we are using vector DBs. So we can use large, high dimensional uh, data, unstructured data can be handled using vector DBs. So this is the only reason we are going for vector DB. Now I'll tell you how actually the data will be stored in a vector databases and how it actually reads your input. So when I say high dimensional unstructured data, it can refer to your text is like major one. Majorly used input is text, image, and sometimes we can use audio also. This also comes under um unstructured data. Uh, why? Because like if you're going for any take out text input, like you have like large paragraphs, and a human being reading the text, they can understand the meaning, and manually, if they are doing, they can just actually group and understand it. Even if they wanted to summarize, they can understand the entire paragraph and do. Like what if we have like millions of papers? Uh, Not even millions, like hundreds, take hundreds also. It is like difficult for a human being to summarize all together. For that, we'll use a LLM kind of. But LLM is not just prompt basically, it is of multiple steps before, if you're like processing the entire required results. For that, in Vector DB, if you are going for any text input, let's say like context, we take. So when we feed the context, which is your text basically, it goes into embedding. So here embedding is, as we know, it should convert your text into numerical format. But how it actually converts that into numerical format is it will use a transformer in it. So transformer basically what it does is it is not just converting your text into numerical format. It understands your text, the semantic meaning and relationship in text, and converts that into a numerical format. For example, let's say you're taking an alphabet of English alphabets, A to C, which is 26. So it starts from 0 to 25 or something. Yeah, 25. So your token size is 25. It assigns for every character the value A 0, B is 1, C is 2, like that. So likewise, we have like multiple transformers, like sentence transformers available in Hugging Face or your own. I mean, there are like different transformers available in Gemini also. I mean, not Gemini, Google offers. So Hugging Face is one among the platform where you'll have like many sentence transformers. Depends on the size like of your tokens. You can use 356, 7, 356, I guess. If you're, sorry, 356. And if you wanted something like really big, 1024. So, like that, you can choose based on the context size. For example, if you're like having a huge email thread, you can go for a 1024. If you're like having like a really large thread, like 500 conversation is happening between group of people, they can actually use 1024 or even 2k token size of sentence transformers just to have the context ready. So if we need to summarize it properly, they can use. So sentence transformers, with the help of sentence transformers, this vector embeddings will be happening. Basically, embedding models, then it stores each values as vectors embeddings. Like you will have values like 0.9 minus 1 to 0. Like 0.176. Likewise, you will have a vector score for uh, every row of data or every set of data that you're feeding it. It may be row wise or page wise, anything as per your preferring it to have. And then we are storing these things into a vector DB. So in vector DB, we'll have everything as a clusters, like group of clusters. As we have the vectors values here, so based on the similar, I mean the distance between each other, it can actually group with that, like cluster 1, cluster 2. This part we know like how the clusters are happening based on the centroids. It assigns the centroids, and with that it finds the uh, equal or similar distance between it or close towards the centroid. It forms a cluster. So that's how the cluster is formed. So each, not each, like in vector DB, you have to name it as a collection. I mean, it is called as a collection, and you have to name a collection. That is your vector DB. I know. Let me just give you that one second. Okay, let me clearly give you that. So in vector DB, everything will be stored as a collection. So in one collection, you will have multiple clusters. This is your model. If you are going for email classification or something, for email classification, you will have the data. That data will be embedded, and that will be stored in a collection. So don't think you will have like each collection for every row. Only one collection. DB in the sense, it is like naming a table, right? It is like that. Your DB is termed as a collection, and you have to name a collection like anything. It may be email, email model, like that. You have to name a collection, and every time when a new set of data comes in, it just update towards it or add towards it after calculating the embedding. So that's how the collections have been storing the clusters. Collections will have multiple clusters. So that's how it is. And the next part is you need to fetch the data. I mean, through the applications, you need to fetch it, right? So for that, you need a query. I mean, you will write a query through an application. So you're giving an query towards your application, and you'll get back the results in your application using cosine similarity. So that's how you get the required elements or the output from the vector DB. For example, you wanted medicines for your viral fever. You just directly ask the vector DB, and vector DB gives you the similar, not similar, like recommended medicines for viral fever based on your symptoms or the temperature or durations of having a fever. So this is what the vector database, and it is very important if you are working in LLM, as I said before, not vector like handling the vector basically. So it is very important to know. And there are like lot of vector databases available like Weaviate, Neon, Qdrant. Everything actually does the job. You just choose based on your interest. Uh, Everything is useful, and it is good to know actually. And If you're working and you wanted to have different models give a effective and efficient results, you need to know all these things, and it is important in current days. So that's all for today. Thanks for watching.